Hello everyone! It is time to do the thing and to remove the controls of the Elka Concorde, the drum and backing synth in the Elka Concorde. I'm gonna remove this entire thing over here and yeah, figure out what I'm gonna replace it with. So, let's get cracking. You know, this is actually the first time in a year that I've seen it from this angle again.
Yeah. You get the classic spaceship angle.
I mean, I had generally kind of forgotten that it looked like this from this angle. So I bought these special pens, which are bright white, sort of paint fine liners, because I need to emphasize some of the areas of the front panel because it's been painted over. Now I did vaguely leave everything visible, all the labels and everything. Yeah, I'm gonna have to very carefully draw it over, probably with a ruler, to make everything a little bit more bright, and hopefully that will work well. Okay, well, that's the first few bits and bobs done. Not too bad. Yeah, worked out pretty well. It's a pain to do, but hey, at least I can read the text now, so that's great. I just got to do everything else. Okay, I'm cleaning up all the knobs and buttons. There's still a few that have like rust in them, especially like this thing is very rusty. There's also a screw in there that's just rust. So that's gonna get the good old chemical bath. Now these are all these silvery buttons, and these are all in a pretty good condition. I'm gonna glue all of them, even if they're not broken yet, just to reinforce them. Cause yeah, this kind of stuff happens a lot. So, and unfortunately, there is quite a few who are just completely just gone. Like, yeah, I can't really salvage this. I could probably 3D print. Ooh, that's a neat idea actually. I could 3D print some the internals and then glue them in place. So this little internal bit, that might salvage those, but yeah, at least these are salvageable. Okay, most of the buttons are back on there. So these are basically all the buttons that were still in a recoverable condition. So yeah, for these I'm going to need to 3D print some. This keyboard arrangement is all wrong. I need to change it. For example, if I press this key, which is white one, this black one is also pressed, which is of course incorrect. And when I look at a type B layout, it is correct. And from what I see in all pictures, it should be type B. This is type C currently, so I need to change that. So I actually have the correct keys. And then I can also have these 4 keys actually have buttons. I'll just skip these 4 or something, because those are extra keys anyways. That's interesting. I seem to have too many black keys, but oh well, at least I'll have to do the top row some other time when I've bought the missing keys, like the missing buttons. Anyways, there we go. Okay, I had to replace the timing capacitor in the solo synth. Now it's playing a nice C. So that's all tuned. Has the tuning knob nicely in the middle. There's a little trimmer on the encoder board, which allows you to adjust the bass tuning, and then you can further adjust it with the front panel control. So I just had the front panel control set to the middle, and then adjust it until I hit C, which is this. Okay, I've opened the Elka up again, because I need to tidy up the inside some more. Still some cables flapping about and it's kind of ugly. And yeah, there's still like the dead note on the string synth and two notes that play at the same time on two keys, which sounds like a short on the frequency generators, because it happens for all the synths, for the organ and string synth and everything else. So. Okay, so this note on the string synth does play the cello, but not the violin. So I'm gonna have to see if something's wrong with this. These capacitors do look very crusty, to be honest, especially this one looks kind of gross. So let's see if I can replace those and if that helps. So I noticed the cello and the violin both had a note that wasn't working, but in different octaves. And since the cello is an octave lower than the violin, that told me there is one frequency that isn't working. And indeed, I measured this one and there's nothing on the scope. So I'm going to need to check around here, I think. Actually, it is one of the frequency generators over here, where this yellow bodge wire goes to. That one isn't working on one frequency, so I need to see what's up. Well, I swapped out a 4040 counter and now the note works again. So yeah, it was one of the counter ICs in here, so I need to get a new CD4040 to replace the one I swapped it with. Okay, so there's two notes playing on two of the keys, two notes at the same time, and I suspected the frequencies because it also happened on the organ and everything else. And yeah, this should be a square wave, but this is clearly two square waves mixed together. So on this connection, this wire somewhere over here, there's probably a short. So I'm gonna have to fix that. Well, something smells very toasty. And I noticed that the chip that was here had some blackened legs, and pulling it out, the socket is also blackened. And this is the chip in question, and you can see it's bulged. So yeah, this 4040 got really toasty for some reason. So that's the second 4040 in that place that has died now. The previous one actually didn't commit Sudoku, but yeah, now this one has. So there's something super wrong with that, the connections on that socket somewhere. So I'm cleaning up my desk and look at all these old capacitors that are replaced. Wow. Well, I removed my custom frequency dividers and frequency generators. You can see the socket of the chip that shorted. It's completely melted, so that was pretty brutal. Anyways, I realized that my Antonelli organ, that little table hooter organ, has the same frequency divider chips, at least ones that are fully compatible. So I simply just fully restored this. And honestly, the sound is much cleaner and a little bit brighter now. So yeah, I think this thing is gonna go into the Antonelli now, because of course that's not working now. But that's fine, because yeah, the Antonelli is table hooter. It's very simple, and you know. So I'm left with these two broken octave dividers. They do sort of work, but they have like one or two dividers that aren't properly working. So I guess I'll just chuck these in the bin. Rip. Okay, I've replaced a little Zener in there, because the old Zener was looking a little bit crusty. And I know why the tuning was so off, because there was 7.5 volts on the power rail, which should be more around 5 volts. I replaced the Zener, it's around 6 volts now, but that's fine. I was just worried about the 7.5 volts being higher than the maximum rating of that the master oscillator chip, this one. It did run fine, it has run fine all this time, so didn't seem bothered by it, but yeah, I was a little bit worried that it would cause long-term damage. So time to put that board back into its slot and yeah, test a little bit more. Oh yeah, and I need to retune it now. Okay, with the frequency generator sorted out, I still have two issues to solve with the treble keyboard. One is that all my G notes are D notes. There seems to be a short between A sharp, the second octave, and F, the third octave, because I measure like a double square wave on those contact points, and I tested continuity, and there's indeed that short between those two. Problem is, where is it in here? So, not figured out that one yet, but I have figured out why, and that's the second problem. The fourth footage of the treble keyboard of the drawbar organ isn't working. The lowest octave is not working. The other octaves are fine, but the lowest isn't. Now, I thought, let's check these inputs over here. So these wires connect to the switching boards for the mixer of the organ. So those are all the transistor-based switches which turn on and off the various footages. And I'm thinking one of the transistors on the middle board here is broken, because when I measure these wire connections over here for the 3 higher octaves, I indeed get a signal. For the lowest octave, which isn't working, I also get a signal. So clearly it's all working, but my hunch is that it's not going from this board to the rest of it. I know it's not the later boards, because at this point all the various footages and the various octaves get mixed together per footage and then goes to the filters. It's basically a separate filter per octave, more or less, depending on which footage. So you get nice sine waves, sort of. So I know it has to be here. So if we look on the service manual, this is those switches which turn everything on and off. And here's the 4 octaves of the fourth footage. Now it goes from the highest octave to the lowest. So octave 1 is the highest octave and octave 4 is the lowest octave. And you can see that the signal comes in from the drawbars and then gets switched on and off by this transistor over here. And this transistor connects to ground. So if there's a high signal on here, this will pull the signal down to ground, essentially muting it. So I'm going to guess that T4 over here might be a short. Maybe it just burned out from age or something. So I'm going to need to check T4. So here we have board 901. I already marked which transistors are which footages, so that's easy. I'm going to have to check one of these. I'm gonna use the diode tester of my multimeter for that. So let's see which one is broken. Okay, I measured the transistors and they seem fine. So maybe it's a short somewhere in the wiring or the outputs. Well, after a lot of faffing around, it suddenly started working, and I think there was a broken solder joint on like the output resistor, because I had a signal up until there, and at the end of the resistor I still had a signal here, but right next to it I didn't, to the connection. So, and seems to be working. So yeah. Now I need to fix my D's and G's. Okay, so I checked that whole motherboard, seems fine. I started to check this one, the quartz board. So the first slot over there and the 8th one both have the F node 3 and A2. And I see that F3 on the 8th board doesn't have a signal, and right next to it is A, which has the weird double node, and also the weird double node on the first one. So I'm going to check the 8th board, the connections on the bottom there. So here we have the connector of the 8th board, and you can see that F3 and A#2 are right next to each other. And this one has no signal, and this one has a double signal. So that's kind of suspect. So I'm hoping that's what I'm looking for. Well, that was extremely finicky, but I moved the white wire from red wire to the, which is A#2, to the F3, and now everything sounds normal. So I hope the cords still work after this. Because that was a pain to do. Okay, it's looking beautiful. Now I need to paint this little section over here, since this is going to be all custom controls now. This little area over here is going to be the new controls for the Elka mat for the drums and backing, and the rest of this is all going to be mods. Well, and there we go. So that is painted now. You see a little bit of a color difference between what's painted and not paint, because I very lightly spray painted this area. Mostly this area. It's a bit too lightly painted previously, but there's nothing I can do about it now. And so now I can leave this to dry for a few hours. Then I can mount the framework on the inside, which holds the switches that were here and the knobs and slider here. Okay, I found a bunch of long wires, so I can hook up the mods. Okay, time to start installing the mods for the Leslie. It's gonna be exciting. There's a 15K resistor over here above the full switch for the Leslie. I replaced this 15K resistor with a 100K potentiometer, which is this knob over here. And basically by doing just that, and I have a controllable depth that's also overrideable by the full switch. So the switch still works as intended, but I also have a control. I also adjusted trim pot number VR1 on board 774, which is also a depth adjustment. I set the value of the resistor a bit on the low side, so that this knob has more effect. And now okay, so I replaced R6 on board 774 with this slider on the front panel here, which should now allow me to adjust the speed. And again, the switch, the original switch on the front panel, again bypasses the mod, the control, so that switch is still functional just like it was originally. Okay, next mods. Again on board 774 I put this variable resistor of the front panel in series with the resistor R.O.T, which is a 47K resistor, which determines the delay time. It's basically just a current limiting resistor for charging a capacitor. So by varying that resistor, we vary the speed of the charging of the capacitor. So this is it set to minimum, which is the normal delay speed. And this is it set to maximum. So it's a pretty subtle difference. I think the larger resistor would probably have worked a little bit better, but it is a pretty nice difference. I might still tweak that, but for now this is pretty good. Okay, here we have the filter board of the mono synth. There's two trimmers here and here for setting the resonance of the low pass and the high pass filter. And that's these two trimmers, and they're set to 40 kilo ohm and 30 kilo ohm more or less respectively, and I'm gonna replace them with two 50K potentiometers. Actually, I'm a little concerned with running long wires through which audio goes. Plus resonance is really sensitive to noise, so I'm thinking I have these LDRs and they go down to like 300 ohms, so that is perfect. So I've been kind of testing, and it goes between like 100K and 300 ohms, so that's the perfect range for making a factoral. That will separate the control signals and any noise from this circuit, keeps the circuit path well, basically the same as the originally was, and yeah, it should give less noise issues. Plus I need to try 3D printing these factoral housings, see how that goes. Okay, I put the factorals in place so I can test some things, and yeah, hopefully it works. Okay, it's a bit crude, but I have it wired up. So this is gonna be the resonance pot for the low pass filter. Here we have the two resonance control wires for the factorals. So the red one being for the high pass, the yellow one being for the low pass, which is currently connected. And just simple pot between 12 volt and ground, with the voltage divider, and a 1K resistor to protect the LED, of course. So this is without any resonance. I'm gonna crank the resonance all the way up. And listen how smooth it sounds. Okay, I 3D printed a little piece to hold the potentiometers in place, and it's just really simple. Just a little plate with a little edge on it, so it actually fits inside of the open space here. Okay, so that's the first two mods in place. We got the high pass filter resonance and the low pass filter resonance. And then mix it in by adjusting the resonance with the sound. Very briefy. That's a very good first mod. Now I didn't actually need to glue the little plate because the potentiometers themselves actually hold it in place really well. So there you go. It's actually, I can just remove this entire mod just by unscrewing the potentiometers. So that works out really well. And here's the brass board for the treble, which has another Moog ladder filter, and I added another custom Vectral over here to control the resonance, and I replaced the trimmer over here, which controls basically the bass cutoff frequency. I played around with the trimmer and I get a very nice range, so I'm just gonna move the trimmer to a potentiometer of the same value to the front panel. And now of course I need to loom all the wires, which I've been doing a lot.